Welcome back to Engineering Systems. FoodDash has done everything right. 3 data centers spread across 3 availability zones with independent power, independent networking, and independent cooling. The system can already lose an entire availability zone and continue serving customers from the remaining healthy zones. So if this architecture is so resilient, why do companies like Amazon, Google, and Netflix still operate across multiple regions? What failure is FoodDash still missing? In the previous episode, we moved FoodDash out of a single data center and distributed it across multiple availability zones inside the Mumbai region. When one zone fails, the load balancer stops sending traffic there and routes requests to the zones that are still healthy. That is a major improvement, but it only protects FoodDash from failures contained inside Mumbai. If you are joining the series here, the System Design playlist will give you the full architecture we have built so far. A few months later, FoodDash is growing quickly. Orders are increasing, customers are happy, and every monitoring dashboard looks healthy. Then, one morning, every dashboard turns red at the same time. Requests stop completing, every API becomes unreachable, and every database connection disappears. This is not one server failing, and it does not look like one availability zone failing. The entire request path has vanished. The engineering team checks each zone. Availability Zone A is offline, Zone B is offline too, and so is Zone C. 3 isolated zones failing together would be extremely unlikely, so the team looks for the boundary they all share. That is when they realize the failure is not inside the availability zones at all. The entire Mumbai region is unavailable. This is the crucial difference between an availability zone and a region. Multiple availability zones protect you from failures inside one region, such as the loss of a data center. A second region protects you from losing the region itself. The protection boundaries are nested, and each one handles a different scale of failure. A region is more than a collection of separate data centers. It also has regional networking, regional services, shared physical dependencies, and a common geographical footprint. A large network outage, a power grid problem, or a critical backbone failure can affect every availability zone in that area. The exact cause is less important than the result. Users can no longer reach any zone inside the region. FoodDash currently keeps its application servers, load balancers, databases, and backups inside Mumbai. That means every copy of the system is still enclosed by the same regional boundary. If Mumbai disappears, adding a 4th or 5th availability zone inside Mumbai does not help. Multi-AZ cannot solve a regional outage because the redundancy never crosses the boundary that failed. So FoodDash builds a second complete deployment in another region, perhaps Singapore, Hyderabad, or Frankfurt. The new region has its own availability zones, application servers, load balancers, databases, and supporting infrastructure. It is designed to operate independently from Mumbai. FoodDash no longer has one regional deployment with internal redundancy. It now has 2 independent regional deployments. Now, if Mumbai becomes unavailable, a global routing layer can stop directing users there and send them to Singapore instead. The application does not disappear because another healthy region still has everything required to serve the request. Regional failover turns a full outage into a controlled change of destination. Notice that multi-region does not replace multi-AZ. It builds on top of it. Each region still needs multiple availability zones because individual data centers can still fail. Resilience works in layers. Servers address hardware failures. Load balancers address server failures. Availability zones address data center failures. And multiple regions address regional failures. Each layer exists because the layer below it has a limit. But 2 healthy regions create a new architectural decision. Should Mumbai and Singapore both serve users all the time, or should one region wait until the other fails? That choice changes latency, cost, operational complexity, and the way data must be replicated. In the next episode, we will compare active-active and active-passive multi-region architectures and see when each model makes sense. Thank you for watching Engineering Systems. If you are enjoying this journey from simple architectures to the systems behind the world's largest platforms, consider subscribing. And as always, keep learning.